There are lots of different kinds of data out there, but in an overly simplistic way, you can really break down data into two types: relational and non relational. Non relational data is most often referred to as NoSQL. Now, that doesn't mean that NoSQL databases can't use SQL type queries. In fact, most of them do. In fact, it's just become a shorthand name for non relational databases. A relational database is primarily used for structured data. You have a clear definition of the data you want to store. But NoSQL databases are used for non structured data. It doesn't mean that you can't have well defined data, but it does mean that your database does not have what we classically refer to as rows and columns. Now, with relational databases, each table is configured to be about a specific piece of data. And this table is about people, or this table is about trucks, or this table is about violins. But with NoSQL databases, each container, and sometimes they aren't called tables, can contain anything and everything. And of course, with relational databases, each table is optimized for the data being stored in there. NoSQL databases are not optimized that way. They are very simple. You can get data very, very quickly, and you can store enormous amounts of data without much difficulty. But the queries are not optimized. To do that, you actually have to structure your data differently. Think of a NoSQL database this way. Imagine you have a bucket and you're walking down the beach collecting things. You can pick up rocks, shells, sand, glass, or discarded bathing suits and put them all in your bucket. The bucket doesn't care what you put in it. That's a NoSQL database. You can put all sorts of different things in the bucket and it doesn't matter. Each of the things in the database don't have to share the same properties. So you might think that because NoSQL databases can store anything, that they can't be useful for situations where you want certain data quickly and efficiently. That's not true. There's lots of ways to organize your data to make it blazing fast for certain queries. But beyond that, you can also use specific kinds of NoSQL databases depending on the use cases you have. For example, a columnar database organizes data into what looks like columns and rows. These databases can seem very similar to relational databases, but its denormalization approach to structuring data still makes it very quick and easy to use. A document database stores data as blocks of JSON, referred to as documents. Now, this still acts like a bucket of potentially random things, but you can at least guarantee that data is always manageable JSON objects, and that can make querying easier. External index databases store searchable information in other data stores and services, and this makes them very handy for being able to search massive volumes of data and provide near real-time responses. Meanwhile, graph databases are generally built on top of document databases, but their primary purpose is about providing the ability to query for data based on their relationship. So imagine wanting to search for people based on their family or their work or a sports team or even permission assignments. A single person can be associated with many different things. So searching for data based on the relationship type that makes sense in any given context can be very valuable. And key value pair databases are very simple indeed. In databases like this, each piece of data is given a unique key, and the value can be anything you want. So you can do a near instant lookup for your data, provided you know the key. Now, object databases are about being able to store objects. So imagine things like files. Files are a great example of unstructured data. You can store the actual file in an object database and include some metadata like its name or its type to be able to search for it later. And lastly, we have time series databases. This is about storing temporal data. So imagine collecting temperature measurements from a smart thermostat over time. In that case, the key is actually a combination of some stream identifier, like the temperature, and the time. Now, there are lots of unstructured data formats out there, but two specific types are by far the most common. First is comma separated values, or CSVs. Now, at first you might think that CSV files are very structured, but they aren't. Nothing stops someone from saying one row has more properties than another. The only thing about CSV files is that we've agreed that each data point is on its own row and each value is separated by commas. But there's a big flaw to CSV files. If every row can have different lengths, then how do you know which values map to which properties? Well, enter today's most dominant unstructured data notation, JavaScript Object Notation, or JSON. JSON allows us to easily define an object, its properties, and their values. We can store as many objects as we want in a single JSON document, and they can all be different too. We can store arrays of objects and all sorts of different data types. JSON is basically the usurper to XML since it's similar in concept, but a lot more lightweight. Although JSON better be watching out because YAML is gaining some traction. So, how would we go about working with a CSV file? Well, the main thing about CSV files is that they're stored in plain text. Now, we tend to interact with CSV files using tools like Microsoft Excel, but at the end of the day, CSV files are nothing more than text files that we can open up in Notepad if we wanted to. Now, typically, CSV files contain a header row, but strictly speaking, they don't have to. When a CSV file has a header, the general expectation is that every row in the CSV file maps to that header row. So if the third column in the header row is defined as something like hair color, then the expectation is that the third column in every single row of the CSV file will contain the data points hair color. But again, that's all by convention. There's no enforcement of that. And the other thing about CSV files is that they don't capture relationships. So there's no way to tell if one row of data relates to some other row of data. And that's not necessarily a bad thing. Remember that in a NoSQL world, the concepts of relationships is handled differently anyway. And now, how would we go about working with a JSON file? Well, first, there's a massive and key difference between JSON files and CSV files. And that's the fact that each value in the JSON file is stored as a key value pair. So going back to my CSV hair color example, if I was looking at an item in the JSON file, I would see that the specific item has a specific property called hair color and it has a value. Now, JSON files are partially structured. In fact, if you were to look at a JSON file, you'd see that each item in the file is fully defined. It has all the necessary properties and values to define that item. Each property is set to its proper data type and everything. So why is it still considered only partially structured? Well, that's because a single JSON document can contain as many JSON objects as you want, and they can all have different properties. Furthermore, even if there was only one JSON object in the document, there's no way to know that it's following the appropriate schema for the object that it's describing. Now, at the end of the day, JSON is extremely similar to XML. It's much more lightweight, but the concept is the same. There are properties, values, arrays, and as much nesting as you want. And working with JSON is very simple because it's human readable. And one more thing is that JSON is self-describing. If you extract an object from a JSON document, you'll know exactly what that object is. You'll know the properties, the values, and the data types. So unlike the header row in a CSV file, there's no need for some other database, another object, or a header row to describe an object that we're seeing in a JSON document. And lastly, there's a reason JSON has become so dominant. There are tons of huge benefits of using JSON. For example, JSON is hierarchical. A single JSON object can contain the property that itself is another JSON object. You can even define arrays of JSON objects. So you can absolutely define an entire complex system as a JSON document if you wanted to. There's also broad support for JSON. You'd be hard pressed to find an API or a programming language that doesn't support JSON. In fact, that's the next benefit, object support. Virtually every programming language supports automatic serialization from objects to JSON and deserialization from JSON to objects, no matter how complex. And finally, JSON is so simple and lightweight that they are by far the most common type of data stored in NoSQL databases. In fact, document and graph databases are almost exclusively JSON based. One of the most common and powerful NoSQL databases in Azure is Azure Cosmos DB. In effect, Cosmos DB is the flagship database for Azure. Now, one of the biggest draws to Cosmos DB is that it's globally distributed, and that presents all kinds of benefits. It means that you can use it locally regardless of your region, even in China. And it also means that your data can be replicated all over the world. The other big aspect of Cosmos DB is that it's multi-model. And what that means is that there's actually multiple different ways to deploy depending on your specific use case. So let's dig into Cosmos DB a little bit. To start with, let's talk about the bigger features of Azure Cosmos DB. First, it's important to note that Cosmos DB is a NoSQL database. Now, Cosmos DB has incredibly low latency, and that's for two reasons. One, it can be replicated all over the world, and two, it's designed to give responses very quickly. And from a usage and criticality perspective, Cosmos DB's 99.999% uptime means that you never have to worry about the database being offline. Or at least Microsoft is guaranteeing that there will be no unplanned downtime greater than 5 minutes per year total. And even though latency is low with Cosmos DB, response times are guaranteed to be under 10 milliseconds, and that's actually a key aspect. Some operations in Cosmos DB are going to take longer than 10 milliseconds, that's just a reality. But what Cosmos DB does is that it guarantees that you'll get some kind of response within 10 milliseconds. Even if that response is, okay, your query is taking a bit longer than 10 milliseconds, so here's a URL that you can query to get your data when it's done. And that applies to both reads and writes. Now, Cosmos DB also has the ability to configure regional failover, and that can be pretty important. If there's a problem with the Cosmos DB, you're going to want the system to keep running properly. So you're going to want another Cosmos DB instance to take over, right? But imagine you had a requirement where your data isn't allowed to leave a particular region. Well, that's where regional failover comes in. Your data can be automatically replicated to another instance of Cosmos DB in the same region. In fact, that failover is automatic with Cosmos DB. I've worked with Microsoft and Azure for a number of years now, and I can tell you that their automatic failover system is quite good. So good, in fact, that if a data center were to be hit by a meteor, you'd probably never know. And one of the key aspects to failover, of course, is that the data is replicated to multiple instances of Cosmos DB. But the good thing about Cosmos DB is that it implements multi-master replication. And what that means is that the replication of data is performed from each of the different Cosmos DB instances. No one instance is the master. So those are the benefits of Cosmos DB, but what are its advantages? Why use Cosmos DB over any other database in Azure? Well, the main reason to use Cosmos DB over any other database is the guaranteed speed. Or put another way, the guaranteed throughput. With Cosmos DB, you pay for guaranteed responses. For example, if you know that your offering needs to read and write a ton of data every minute, you can tell Cosmos DB that you need that throughput and it will guarantee it. But if you don't need that much throughput, you can keep Cosmos DB cheaper by limiting how much resources that you actually allocate. Now, Cosmos DB makes for highly effective data development because it's fully integrated with lots of other Azure services to enable data flow, and because you can use Cosmos DB in a variety of different ways. So if you have data coming from an IoT hub, an event hub, or even something like Azure Data Factory, you can connect those things automatically to Cosmos DB without writing any code. And then, depending on how you plan to use your data, you can select the right model for you. And we'll touch more on that later. Another advantage of Cosmos DB over other databases is that it's always available. Remember that 5 nines uptime? That's pretty great. Now, that's not to say other Azure services are bad, it's just that Cosmos DB is that good. And finally, Cosmos DB is a fully managed service in Azure. And that means that all the hardware and software updates and upkeep are completely handled by Microsoft. All you have to worry about is managing your data. Now, in Azure Cosmos DB, you can configure whatever consistency level makes sense to you. This will be very important if you have replication enabled. The stronger the consistency, the more latency, lower availability, but the more consistent your data will be across regions. The weaker your consistency, the lower the latency and higher availability, but the less guarantees that your data will be the same in each region. Now, the strong consistency is effectively a guarantee that all your data will be in each region at the same time. A consumer will never see uncommitted or partial writes. In other words, consumers are guaranteed to be able to read the latest committed write. With bounded staleness consistency, reads are guaranteed to be in order, but they have a certain amount of staleness to them. Interestingly, you can configure that staleness, which means that you can actually pull this further away from the strong consistency if you want to. Session consistency is similar to strong consistency, except that it's only guaranteed in the same region. Outside of the region, consistency is no longer guaranteed, and if a consumer attempts to read data, it may not actually get the most recent data. And then there's the consistent prefix. This consistency option guarantees that reads are never seen out of order, but doesn't guarantee their performance. So you'll definitely get the latest data that the database knows about, and you'll definitely get it in the right order, but it won't necessarily be the most actual recent data. And lastly, we have eventual consistency. Eventual consistency makes only one guarantee. All your data will eventually be replicated. There's no guarantee of order, and all it's saying is that your data will eventually find its way to all the replicated databases. Now, there are a number of ways that you'll need to work and interact with Azure Cosmos DB. First, you'll have to manage the data ingestion. How will your data get into the Cosmos DB? Well, to do that, you can use an existing Azure service that automatically integrates with Cosmos DB, like IoT Hub, Event Hub, or even something like Azure Data Factory. But you can also build your own systems that can write data directly to the database so you can manage any sort of custom logic you want. And of course, you'll need to manage your data security. Cosmos DB is pretty secure by default, but you can also add some additional access rules and encryption at various layers depending on your chosen model. And then there's your actual queries, and this is very important. What sort of data do you have? How much? How often does it update? How often do you plan to use it? How do you plan to use it? Specifically, how do you plan to query it? Knowing the answers to those questions can tell you how to configure Cosmos DB to be effective for your specific situation. Now, earlier I mentioned that there are several different ways to deploy Azure Cosmos DB, and that's because it's multi-model and includes a few different APIs. One of the most popular APIs, in fact, is the default API. It's the SQL API. This provides you with a more traditional NoSQL JSON document view, which you can query using familiar SQL syntax. The MongoDB API allows you to interact with your data using the MongoDB protocols. You're still using Cosmos DB, but for all intents and purposes, it'll seem like you're using an actual MongoDB NoSQL database. The Gremlin API is fantastic for modeling your data in a graph format. You can define all sorts of vectors, the objects, and edges, their relationships. In fact, this is so powerful, Microsoft uses it themselves to handle most of their role-based access control. Then there's the Table API. This is a very simple API that allows you to interact with your data as a very simple set of JSON documents. All you need to do is provide a primary key and a row key for each of your documents so that they can be uniquely identified. After that, you can store whatever JSON document you want. And lastly, there's the Cassandra API. This API makes it possible to query your data using the Cassandra Query Language, or CQL. Now, just like with the MongoDB API, your data will look and behave just like a Cassandra system. Now, it's important to be clear about what kind of database Cosmos DB is. Importantly, Cosmos DB is schema-free, and that means that there's absolutely no enforcement on what data is being put into the database beyond a few built-in rules. It's whatever you want. So if you want to store trucks in the same container as people or violins, you can do that. Nothing stops you. But that doesn't mean that Cosmos DB can't help you out there. In fact, Cosmos DB can be helpful and discover how your data is generally queried and implement some indexing automatically to help improve performance over time. Now, underneath the hood, Cosmos DB uses trees to represent your data. Now, anything that comes in and out of Cosmos DB is represented as JSON documents, and these JSON documents are broken down and converted to trees. So each object in the JSON document is represented as a node, but so too are all of the individual properties. And that means searching for values is a little bit easier, behind the scenes anyways, because it turns it into a tree navigation strategy. It also means that there's a pseudo root node in every Cosmos DB container. And finally, let's quickly talk about the different types of indexes in Azure Cosmos DB. First, we have range indexes. Range indexes are great in the tree structure I mentioned earlier. Primarily, these types of indexes are used for scalar values like strings and numbers. And next we have spatial indexes. Spatial indexes allow us to search for data based on their mathematical relationship to other data. So for example, distance and intersect. And lastly, there's composite indexes. Composite indexes are used to combine multiple fields into a single index due to their apparent relationship. So, for example, in a time series database, the stream identifier and the timestamp will almost always be queried together, so you may use a composite index to combine those fields. In this demo, we're going to provision an instance of Azure Cosmos DB using the Azure Web Portal. Once we've provisioned Cosmos DB, we'll explore the service and create some content. Okay, so the first thing we need to do is head over to the Azure Web Portal in our browser. Now what we want to do here is create ourselves an instance of an Azure Cosmos DB. And Cosmos DB is like any other resource in Azure. That is, it's a resource. So to create an instance of Cosmos DB, we need to create a resource. So let's click on the big Create a Resource button at the top of the screen. Now in the search field, let's type Cosmos DB and hit Enter. Now let's find the Azure Cosmos DB result from Microsoft and click on the Create option at the bottom of the box. Now here we are in the Create screen for Cosmos DB. This screen will act like a wizard and guide us through creating our instance of Cosmos DB. We'll start in the Basics tab. First, right at the top, we're being asked for a location to put our Cosmos DB instance into. You can choose whichever subscription and resource group you wish. For me, I'm going to create a new resource group, so I'm going to do that by clicking on the Create New link. And now I'm going to give my resource group a name, and I'm going to call mine SBDemo12. Now the reason I'm doing that is because when I'm done, I can quickly clean up all my resources just by deleting the resource group that I put them in. Anyway, let's give our Cosmos DB instance a name. I'm going to call mine SBDemo1204. Next, we have the API to choose. Here we can choose from all sorts of different implementations of Cosmos DB. But for this demo, let's leave the SQL option. In fact, for the purposes of this demo, we're going to leave all the rest of the options as their defaults. So let's click the Review and Create button at the bottom of the screen. Now, assuming all the validation passes, let's go ahead and click on the Create button at the bottom of the screen. Now, this kicks off the creation process for our Cosmos DB, and this might take a moment, so I'm going to fast forward until it's completed. Perfect! Our Cosmos DB instance is created. So let's go check it out. Let's click on the Go To Resource button in the middle of the screen. Now, the first thing you might see when you access your Cosmos DB instance is the Quick Start page. Now, this can be handy for a walkthrough if you're new to Cosmos DB, but we're going to ignore this for now. Let's start by clicking on the Overview menu at the top of the screen. So like any resource in Azure, the Overview page gives you a quick peek into your resource. Here we can see the resource group it belongs to, the subscription, its location, and even its public URL. There's some quick insights at the bottom of the screen too. Next on the menu is the Access Control section, so let's click on that. Now this section allows you to control which users and groups have what sort of access to this resource. For example, in the past, I've granted people permissions to query the database but not to be able to update it, and I can do that from this section. Now if you scroll down on the left-hand menu, you'll see all sorts of other features for Cosmos DB too. You can configure replication policies, backup plans, manage access keys, set up monitoring, inspect database metrics, and of course, initiate support requests. But what we really want to do with our database is, well, play with the data. So let's do that. In the top section of the menu, let's click on the Data Explorer option. Now what this page does is allow us to interact with the data in our Cosmos DB instance. But since our Cosmos DB instance is completely new, we don't have any data. So let's create some and see what that looks like. Now Cosmos DB organizes data into what's called databases. Databases allow you to completely isolate data from other data. You can also set up different rules for each database. Let me show you. Let's create a database now. Click on the down arrow to the right of the New Container Toolbar button. And now let's select New Database. Now in the panel on the right, we're actually being asked to give our database an ID, so let's do it. I'm going to call mine SB database. Next, we're being asked to select a database throughput type. Now we can choose auto-scale or manual. This is how Cosmos DB is billed. What you're doing here is you're asking for guaranteed throughput. Your objective here is to select a throughput that'll be enough for your workload, but not so huge that it bankrupts you. Autoscale can be good for that because Cosmos DB will charge you 10% of the configured throughput, but allow for elastic scaling up to your maximum. So you'll only get charged for huge load if you have huge load. The point is that you should try to understand your data patterns before creating a database. Anyway, let's leave it as the defaults because that's the cheapest option. So at the bottom of the panel, let's click OK. Now this might take a second, so let's wait for it to complete. We now have a database, so let's click on it. Now notice that the only option we have is scale, so let's click on that. Now see here that we can change the scale if we want to, but be aware, you can scale up very easily, but depending on your usage patterns, you might not be able to scale back down. So be very careful. Anyway, we have a database, but we still can't save any data, and that's because we don't have a container. A container is where data actually gets stored, and containers are placed in different databases. So let's click on the New Container button in the toolbar. Now we're being asked to create a new database or to select an existing one. Well, we created a database already, so let's click on the Use Existing Radio button, and then choose our database. Now we're being asked to give an ID for our container, so I'm going to call mine SB Container. And lastly, we're asked to give a partition key for our data. Now, this is a bit of data that you'll provide that will help to group your data. The values in the partition key don't have to be unique, but there is a maximum of 10 gigabytes of data allowed in a partition. So for example, I've used timestamps down to the minute as partition keys. That means that I can have lots of data in a single partition, but it's unlikely that I'll have 10 gigabytes of data in any given partition. But since this is a demo, I'll just make something up. I'm going to put the value of /foo. Now note the slash. That's required to show that the field is at the root of the document that we'll put into the database. It also means that I'll have to have a field called foo. Anyway, let's click OK at the bottom of the panel. We now have a container in our database, so let's click on it. Now notice that there's an item option under our database. Let's click on that. Now this lists all of the data in our container, and of course it's empty. Notice too that there's a foo column listed. Now at the top of the screen, I can also filter the data by giving a particular query too. But let's go ahead and create some data. Now at the top of the screen, let's click the New Item button. Now notice that we're given a block of JSON. Now what we're going to be saving here is a JSON document. The ID value is mandatory, but we have to give this document a unique ID. So let's start by setting the value to something like 123. Now let's add a comma to the end of the line. And on the next line, let's add our foo field. And then give it a value of something like bar. Now let's add one more field for good measure. Again, we'll add a comma at the end of the line. And on the next line, let's add the field baz with the value of 456. Now notice that I'm setting the value as an actual number. It doesn't have to be a string. Now at the top of the screen, let's click the Save toolbar button. Now notice that the item that we've saved appeared on the side and that our value of bar is shown under the foo column. But the big thing you'll notice is that our item now has all kinds of other junk in it. All the properties with an underscore are properties that Cosmos DB automatically inserts to maintain information about your document. For example, the _TS property is the numeric timestamp of when the document was last updated. Now pay attention to this value. Anyway, let's edit the document. Let's change our baz value to 789. And now let's add a property called cas. And let's set its value to false. Now let's click the Update toolbar button. Excellent! Our document has been updated. And notice that the _TS value has changed to a new time. Now lastly, let's remove our document. To do that, We simply need to select our item from the side list, and obviously ours is already selected, and then click on the Delete toolbar button at the top of the screen. And now we confirm the deletion. Our document is deleted. And so that's it. Now at this point, we provisioned an instance of Azure Cosmos DB, we created a database, we created a container in that database, and we added, edited, and removed an item in that container. Probably one of the most basic and yet fully featured data service options in Azure is Azure Blob Storage. Blob storage is highly versatile. Blobs are the most basic data type in Azure. They can be anything. So Azure Blob Storage is about serving those blobs, and that can mean servicing things like images and documents to a browser. Blob storage can also be used for audio and video streaming. And as blob storage is widely distributed across Azure, it also means that storing files in blob storage allows for distributed access. Another way blob storage is often used is to handle simple things like writing to log files. And blob storage can also be used as a system to perform backups, restore backups, and even archive those backups. And one more way that blob storage can be used is to perform data analysis. Now, Azure Blob Storage is not only highly versatile, but there's also a myriad of ways that you can access it too. For example, of course you can access the database using the standard web portal. That's probably the simplest and most intuitive way to get at your data. But you can also use the Azure Storage REST API. With the API, you can perform every action that you can in the web portal. The REST API allows you to use whatever tool or programming language that you're comfortable with. Another tool you can use to interact with blob storage is Azure PowerShell. You can use PowerShell either on your desktop or directly in the cloud. Then you can simply execute commands to do whatever you need with your blob store. Now, similar to Azure PowerShell, there's also Azure CLI. In fact, aside from slightly different syntax, CLI is still based on command line actions to perform whatever action you want. And finally, there's the Azure Storage Client Library. Now, these libraries can be used in a variety of different programming languages to let you implement whatever logic you see fit when communicating with your blob store. Now, there's actually several different client libraries that you can use to connect to your blob store. The reason that there's multiple libraries is simply because Microsoft supports access from a multitude of different programming languages. Of course, there's .NET, that's Microsoft's language. Java is supported, so is Node.js and Python, Go, PHP, and even Ruby. So Microsoft provides a client library for the majority of the popular programming languages out there. But that being said, even if you're using a programming language that isn't supported, you can always revert to the REST API. Now, blob storage in Azure is actually typically handled by Azure Storage Accounts. In Azure Storage Accounts, there's a certain set of resources that comprise blob storage. It's useful to understand those terms. Now at the top, we have the actual storage account. A storage account is the actual Azure resource that you would provision. A storage account contains 4 different data services: blobs, files, queues, and tables. Now when we talk about blob storage, we're really talking about the blob data service in a storage account. Now within the blob data service portion of a storage account, we have the concept of containers. A container is a point of isolation between data. For example, you can choose to store one customer's data in one container and another customer's data in a totally different container. They'd both be managed by the same storage account, but the containers themselves would be completely isolated from each other, so the customer data would never touch or be shared. You can then give different permissions to each container to different users. And finally, we have the blob itself. Blobs are stored in containers. Blobs can be organized into folders, and they themselves can be given certain properties regarding access and encryption. But at the end of the day, a blob is your data. And lastly, if you're going to set up an Azure storage account for the purposes of blob storage, here are some best practices that you might want to follow. Now, ultimately, there's only one best practice, and that's data protection. Now, obviously, you should organize your data according to your query needs, but that's going to be different for everyone. But what you should do as a best practice is protect your data. There's actually a number of ways to do that. First is to use identity and access management features, or IAM. With IAM, you can grant specific users or groups or even apps and services specific access to your data. You can go as granular as you want to as well. You can even give people access to the entire storage account or individual data services, maybe even specific containers, or even specific folders in a container. Another way to protect your data is through networking. Now, enabling virtual networks with firewalls and hard lines can prevent anyone from accessing not only your data, but the entire network of resources where it sits. In that case, users are denied access to the database. In fact, they don't even get close enough to the database to be denied access. They're blocked at the firewall. And finally, once you have all that data protection in place, you can then use the monitoring and logging features within a storage account to watch how data is being accessed so that you can make whatever changes you need to if further protections are required. In this demo, we're going to provision an Azure storage account using the Azure Web Portal. Once we've provisioned the storage account, we'll explore the service, create a blob container, and then upload and download a blob. Okay, so the first thing we need to do is head over to the Azure Web Portal in our browser. Now what we want to do here is create ourselves an instance of an Azure storage account, and storage accounts are like any other resource in Azure. That is, that they're resources. So to create an instance of a storage account, we need to create a resource. So let's click the big Create a Resource button at the top of the screen. Now in the search field, let's type storage account and hit enter. Now let's find the storage account result from Microsoft and click on the Create option at the bottom of the box. Now here we are in the Create screen for the storage account. Now this screen will act like a wizard and guide us through creating our instance of a storage account. We'll start in the Basics tab. Now first, right at the top, we're being asked for a location to put our storage account instance into. You can choose whichever subscription or resource group you wish, but for me, I'm going to put my storage account in the same resource group that we used for our Cosmos DB demo earlier in this course. I'm going to put my storage account in the SB Demo 12 resource group. Now, once again, the reason I'm doing that is because when I'm done, I can quickly clean up all my resources just by deleting the resource group that I put them in. Anyway, let's give our storage account a name. I'm going to call mine SB Demo 1206. Now let's choose the locally redundant storage option from the redundancy list. This will keep our costs cheap and easy. Now let's click the Review and Create button at the bottom of the screen. Now, assuming all the validations pass, let's go ahead and click the Create button at the bottom of the screen. Now this kicks off the creation process for our storage account, and this might take a moment, so I'm going to fast forward until it's completed. Our storage account instance is created, so let's go check it out. Click on the Go To Resource button in the middle of the screen. Now the first thing we see when we access our storage account is the Overview page. Now this page gives us a quick peek into our resource. So here we see the resource group it belongs to, the subscription, its location, replication strategy, and so on. There's even some quick insights at the bottom of the screen too. Now next on the menu is the Access Control section, so let's click on that. This section allows you to control which users and groups have what sort of access to this database. For example, I've granted people permission to query these databases but not to be able to update it, to add things to the queue but not be able to read anything. I can do that from this section. If you scroll down on the left-hand menu, you'll see all sorts of other features for storage accounts too. You can configure the various data services, manage security including keys and networking, set up replication policies, configure monitoring, inspect database metrics, and of course, initiate support requests. But what we really want to do in our database is play with the data. So let's do that. Now in the top section of the menu, let's click on the Storage Explorer option. Now what this page does is allow us to interact with the data in our storage account. But since our storage account is completely new, we don't have any data. So let's create some and see what it looks like. Now storage account has 4 types of data services: Blob, File, Queue, and Table. Now each one of them offers specific capabilities, but for our purposes, we'll use the most basic, yet full-featured data service, Blobs. Now, storage accounts organize Blob data into what's called containers. Containers allow you to completely isolate Blob data from other Blob data. Now you can also set up different rules for each container. Let me show you. Let's create a Blob container right now. Right-click on the Blob Container section and select Create Blob Container from the option list. Now in the panel on the right, we're actually being asked to give our container a name. So let's do that. I'm going to call mine SB Blob Con. Now let's expand the Advanced section. Notice that above the Advanced section, we can set public or private access levels, and inside the Advanced section, we can choose an encryption strategy. And that means that we can configure each of our blob containers differently if we want to. Now, for the purposes of this demo, I'm going to leave everything as the defaults. So at the bottom of the panel, let's click Create. Our blob container is created. Let's expand the blob containers section just to make sure. There it is. So now that we have the container, let's click on it. Now this screen shows us a list of all the blobs that we have in our blob container. Now obviously our database is totally empty, so our list is also empty. So let's go ahead and create some data. First, let's flip over to Notepad. Now let's create a simple text file with some dummy data. I'll create a file with a couple of names in it. Jones, Alice, Johnson, Bob. And now I'll save the file as names.txt. Now let's flip back over to the Azure portal. Now let's go ahead and add our file to the blob storage. At the top of the screen, let's click the Upload button. Now in the panel on the right, let's browse for our file. Next, let's open the Advanced section. Now notice that we're given a bunch of options where we could add extra details and settings to our blob. Now we're going to mostly leave this as the defaults, but let's do one quick thing. In the Upload to Folder field, let's give it a dummy folder. I'm just going to call mine something like foo. Now let's scroll to the bottom of the panel and click Upload. You can see in the background that our file has been added, or at least the folder has, so let's close the panel, and now let's double-click the foo folder. And there's our file! Great! Now let's download the file. Make sure the file is selected, and mine is. And now let's click the Download toolbar button at the top of the screen. Now notice that we're prompted to download the file in a separate window. So let's click the Click Here button to get the download started. Now let's open the file. That's our file! Fantastic! Lastly, let's remove our document. Let's go back to the browser. Now let's click OK to get out of the download prompt. And now, since our file is already selected, let's click on the Delete option in the More toolbar button submenu. Here we're being prompted to confirm the delete. And notice also that it's giving us a safety net that our file won't actually be deleted for 7 days. So if we realize that we've made a mistake, we have that much time to restore our file. Anyway, let's confirm the deletion by clicking the Delete button at the bottom of the panel. Our blob is deleted. So that's it. Now at this point, we've provisioned an instance of an Azure storage account. We created a blob container. We created a blob in that database. We downloaded that blob, and then we deleted it from the container altogether. Another common data service in Azure is Azure Data Lake Storage Gen 2. Data Lake Gen 2 is primarily geared towards performing big data analytics. Now, unlike most services in Azure, Data Lake Gen 2 is not deployed as its own resource in Azure. Rather, it's deployed as a capability within another Azure service, Blob Storage, or more specifically, Azure Storage Accounts. Data Lake Gen 2 is more appropriately described as a set of capabilities that are attached to a storage account. Now, what Data Lake brings to storage accounts that storage accounts don't already have is the ability to handle and process massive amounts of data. Storage accounts can already handle a huge volume of data, but what we're talking about here with concepts like big data analytics is we're actually talking about gargantuan amounts of data. Now, Data Lake also increases the throughput capabilities of storage accounts, and that makes sense, right? If you need to process massive amounts of data, then you'll also need to handle the throughput of that data. But the big addition that Data Lake Gen 2 brings to storage accounts is hierarchical namespaces. Hierarchical namespaces help organize objects and files into a hierarchy of directories. Now, you might think that blob storage already has that, but that's not really true. What's actually happening behind the scenes is that the blobs are named with slashes as delimiters. Then interfaces automatically parse those names and render information as if it was folders. Hierarchical namespaces actually implement a proper folder structure. Now, Azure Data Lake Gen 2 brings a lot of features to the table. For example, the overall performance of Data Lake is optimized because there's no need to copy or transform data before analysis. Plus, the hierarchical namespace improves performance even more because the data that you need is highly organized and easy to get to. And what else does folders do for you? Well, they greatly increase efficiency and management. All your data is organized and easy to handle and easy to find. Another wonderful feature of Data Lake Gen 2 is how it handles security. And again, that's all centered around the folder concept. With these directories, you can manage security of the storage account, the containers, and even each individual folder however you wish. But there's other features that aren't just about folders. For example, Data Lake includes the ability to manage and access data just like you would with a Hadoop distributed file system or HDFS. That Hadoop compatibility can be extremely handy depending on the services that you want to plug into your storage account. And like most services in Azure, Data Lake Gen 2 includes an optimized driver or library that you can use to interact with the service programmatically. And if you can't use that driver for whatever reason, then you can always use the REST API that's available. Now, I mentioned earlier that one of the features of Data Lake Gen 2 is how it handles security. Well, not only does it support ACL, meaning access control layers, but it also implements POSIX permissions. And these settings can be configured right in Storage Explorer, or you can use other frameworks like Hive or Spark. And lastly, Data Lake Gen 2, for all its features and capabilities, is cost effective. Storage costs are dirt cheap, which is useful considering it needs to store massive amounts of data, and transaction fees are pretty minimal too. So Data Lake Gen 2 sounds pretty good. How would we go about working with data in that service? What are the typical actions that someone would take? Well, the first thing you do is ingest data. Obviously, it's a bit silly to use Data Lake without actually having some data in there, right? Well, there's lots of ways to do that, be it real time or in batches. And there's also lots of different tools that can feed the system. But the first thing you do with Data Lake is ingest that data. And the next thing you do is process the data. And that can be through analytics, normalization, or any other calculation that you might want to do. Again, there's lots of tools that can easily connect to Data Lake and perform just about whatever processing you want. And another thing you want to do is download your data. You've collected a bunch of data and you've performed all this processing on it. Clearly, you're going to want to read that data for one purpose or the other, right? And the last thing you'll want to do is visualize the data. Now, whether that's feeding your data to tools like Power BI or whether it's just manually inspecting the data through something like Storage Explorer, whatever the reason, visualization is a core activity. Now, Data Lake Gen 2 can be used to store lots of different kinds of data, and some of the common data types are things like simple ad hoc data storage, or even the storage of an entire Azure HD Insight cluster. Data Lake Gen 2 can even be used to store Hadoop clusters either from the cloud or on site. And while there might be some more efficient sources for it, Data Lake can be used to store massive amounts of relational data too. Even stream data can be stored in Data Lake. But at the end of the day, Data Lake is generally about storing very large data sets. And one last case that's sometimes overlooked is the storage and continual update of web server logs. Blobs are great for that, and Data Lake extends blobs to the extreme. Now, once the data has been stored in Data Lake Gen 2, that's when you can begin your processing step. There's lots of tools that you can use to perform big data analysis against your data in Data Lake. But the most common and proficient Azure services that can handle your analytics are HD Insight and Azure Databricks. Both HD Insight and Databricks are specifically designed to perform big data analytics in Data Lake, and both have an explicit connector for Data Lake as a result. But what about visualizing your data? Well, visualization is often a highly custom thing, especially if you're trying to create an offering that you can sell to your customers. So typically, people create their own visualizations. But if your goal is simply to be able to visualize the data, then there's a very robust and common tool in the Azure ecosystem that you can use: Power BI. Data Lake Gen 2 includes a Power BI connector that allows you to feed your data directly from Data Lake into Power BI. And then you can use Power BI to generate your various visual representations of your data. There are tons of charts and widgets that you can use in Power BI to render your data effectively. In fact, Power BI is getting robust enough that some businesses are using it as their customer portal. And lastly, let's talk about downloading data. You have all this data in Data Lake, and you want to be able to download some of that data for various other operations. So, what are your options? Well, I would be remiss if I didn't start with Azure Data Factory. Data Factory's primary purpose is to connect to data sources like Data Lake and move data around to other sources. You can even use Data Factory to augment the data during the transmission. Now, Azure Storage Explorer can be used either directly in the cloud or on your desktop to interact with your data. You can explore your data, run queries, and even manage your containers if you need to. And then there's Apache DistCP. DistCP can be used to copy data between Data Lake and Blob storage. And finally, we have AZ Copy. Now, AZ Copy is a fairly straightforward tool for Microsoft that's able to connect to just about any data source and copy selected data to whatever location you wish. Now, that can be another data source or just locally to your system. In this demo, we're going to provision an instance of Azure Data Lake Gen 2 using the Azure Web Portal. And once we provision Data Lake, we'll explore the service and manage some content. Okay, so the first thing we need to do is head over to the Azure Web Portal in our browser. Now what we want to do here is create ourselves an instance of an Azure Data Lake Gen 2. Now, the Gen 2 Data Lake is not like any other resource in Azure. That is, it's not its own resource. So you don't so much create an instance of Data Lake Gen 2 as you enable its capabilities in another service. In fact, the service that you use to enable Data Lake Gen 2 is a storage account. So to use Data Lake Gen 2 features, you need to create a storage account resource first. But it can't be any old pre-existing storage account. We have to enable certain features during creation time. You can't convert an existing storage account to use Data Lake Gen 2 features. So anyway, let's go ahead and create a new storage account. Let's click the big Create a Resource button at the top of the screen. Now in the search field, let's type storage account and hit enter. Now let's find the storage account result from Microsoft and click on the Create option at the bottom of the box. Now here we are in the Create screen for the storage account. This screen acts like a wizard and guides us through creating an instance of our storage account. We'll start in the Basics tab. Now right at the top, we're being asked for a location to put our storage account. Now you can choose whichever subscription and resource group you want, but for me, I'm going to put my storage account into the same resource group that we've been using for this course. I'm going to put my new storage account into my SB Demo 12 resource group. Now once again, the reason I'm doing this is because when I'm done, I can quickly clean up all my resources just by deleting the resource group that I put them into. Anyway, let's give our new storage account a name. I'm going to call mine SB Demo 1208. Now in order to use Data Lake Gen 2 features, we need to set a very specific set of options in our storage account. We need to set the type of account to either Standard General Purpose 2 or Premium Block Blob. For our purposes, let's set the performance setting to Premium, and then set the Premium account type field to Block Blobs. Now the next thing we need to do is enable the hierarchical namespace setting. So let's click Next at the bottom of the screen and head over to the Advanced section. Now let's scroll down to the Data Lake Gen 2 section. Now let's go ahead and enable the hierarchical namespace setting by clicking the checkbox. Now we can leave all the other settings as their defaults and start the creation process. So let's click the Review and Create button at the bottom of the screen. And now, assuming all the validation passes, let's go ahead and click the Create button at the bottom of the screen. Now once again, this kicks off the creation process for our new storage account, and this might take a moment, so I'm going to fast forward until that's completed. Our new storage account instance with Data Lake Gen 2 features is enabled and created. So let's go check it out. Let's click on the Go To Resource button in the middle of the screen. Now the first thing we see when we access our storage account is the Overview page, and this page gives us a quick peek into our resource. So here we see the resource group it belongs to, the subscription, its location, replication strategy, and so on. And there's even some quick insights at the bottom of the screen. But right away at the bottom of the screen in the Properties section, you're seeing that this storage account is using Data Lake storage. Beyond that, you'll see most of the normal options in the left-hand menu, so you still have the Access Control section to manage permissions, you still have the ability to manage security, including keys and networking, and set up replication policies, configure monitoring, inspect database metrics, and of course, initiate support requests. But one of the main differences between a Data Lake Gen 2 enabled storage account and a regular storage account is in the data management. So let's take a look at that. In the Data Storage section on the left-hand side, click on the Containers option. Now you might remember with a regular storage account that we usually see 4 main data services in the Data Storage section: blobs, files, queues, and tables. But with our Data Lake Storage Explorer, we're only seeing containers. Now Data Lake Gen 2 storage accounts organize their data as files, and the files are divided into relevant containers. Containers allow you to completely isolate data from other data. Let me show you. Let's create a container now. Click on the New Container toolbar button at the top of the screen. Now in the right-hand panel, we're actually being asked to give our container a name, so let's do it. I'm going to call mine SB Container. Now let's leave all the rest of the settings as their defaults and click Create at the bottom of the panel. Our container is created, so let's click on it. This screen shows us a list of all the files that we have in our container. Now, obviously our container is totally empty, so our list is empty. So let's go ahead and add some data. Now in our last demo, we created a file called names.txt with some names in it. So let's use that same file again. Let's go ahead and upload it to the container. Now at the top of the screen, click the Upload toolbar button. Now in the panel on the right, let's browse for our file. Next, let's open the Advanced section. Now notice that we're given a bunch of options where we can add extra details and settings for our files. Now we're mostly going to leave this as the defaults, but let's do one quick thing. In the Upload to Folder field, let's give it a dummy folder. I'm just going to call mine Foo. Now let's scroll to the bottom of the panel and click Upload. So you can see in the background that our file has been added, or at least the folder has. So let's close this panel. And now let's click on the Foo folder. And there's our file. Now let's download the file. Now at the end of the line, let's click on the ellipsis button. And now let's select the Download option. Now let's open the file. That's our file. Fantastic. Well, lastly, let's remove it. Let's go back to the browser. And now let's click on that ellipsis button again, and this time let's select Delete from the list of options. Now let's confirm the deletion by clicking the Yes button at the bottom of the pop-up. Our file is deleted. Now the advantage of a Data Lake Gen 2 storage account is the added features and storage capabilities. We didn't really go into each of those, but you can even see from the left-hand menu that we can actually manage access control to individual folders. Data Lake is pretty powerful, but at the same time, the settings are pretty familiar to storage accounts, aren't they? So anyway, that's it. At this point, we've provisioned an instance of Azure storage accounts with Data Lake Gen 2 features enabled. We created a container, we uploaded a file to that container, we downloaded the file, and then we deleted it from the container altogether. Now, data is obviously an important part to any data-driven activity, but sometimes the data we're talking about is highly sensitive and shouldn't be completely exposed to consumers. So what do we do about that? Well, enter Azure Dynamic Data Masking. Data masking is a policy-based concept that's centered around limiting the exposure of sensitive data to various consumers. The idea is to mask certain data away from unprivileged users. So let's dig into this a little bit. Now, data masking is a vital piece of the puzzle for lots of businesses. Imagine a scenario where you want a user to be able to view a configured payment method, but you don't want that user to actually be able to see all the credit card details. Well, with data masking, you can choose to mask all but the last 4 characters of the credit card. And we see that all the time, right? Now, data masking isn't available in all Azure data services, though. So when we talk about dynamic data masking, we're really talking about using it in an Azure SQL database, an Azure SQL managed instance, and Azure Synapse Analytics. So how does dynamic data masking work exactly? Well, the first thing to really understand is that dynamic data masking works by preventing unauthorized access to specific pieces of data in your dataset. And this is all policy-based security too. So what that means is that you can create actual policies that will dictate which pieces of data can be seen by which users and masked to others. But more than that, you can use these policies to actually assign how much data to reveal. So remember the credit card example? Well, with a policy, you can dictate how much of the credit card number to reveal to users that don't have permissions to the entire dataset. But it's important to note that with good policies, there's little impact on the application layer. Applications that use that data will obviously need to see all the data, right? So if you're charging a credit card, you need the whole number, not just the last four digits. So policies will generally allow application identities to view data and therefore make sure that applications aren't affected at all. And also that data itself remains unchanged with masking. So dynamic masking doesn't actually change any of the data in the database itself. All it does is apply policies to the various read operations that are being performed by users. The data in the database is still in the same raw format. So data masking sounds pretty slick. So how do we actually implement it? Well, there are two ways. The first and most intuitive way is by using the Azure Web Portal. You can access your data service, and remember that's SQL or Synapse, and then use the dynamic data masking blade to access the data masking settings. From this screen, you can create whatever policies you wish on your data. And the other way you can implement data masking is through various tools outside of the Azure Web Portal. So you can create scripts using Azure PowerShell, or you can create custom programs that connect to the data service's REST API. The Azure Web Portal itself exclusively uses the REST API, so if the Web Portal can't do it, the REST API can do it too. Now, as I mentioned already, data masking is configured through something we call a policy, and a policy consists of three main characteristics. First is the SQL users that are excluded from masking. Now, like most things in Azure, the default position is always to be secure. So once you create a policy, it's assumed that it's going to apply to everyone. So if there are users or applications that you don't want the policy to apply to, then you need to explicitly list them. The next characteristic of data masking policies is the actual masking rules. Masking rules define the fields that actually need to be masked and what masking functions to use when doing so. The fields are defined by providing the database name, the table name, and the column name. Now, as for the masking functions, the third characteristic, there's a whole bunch of functions that you can use. These functions define how the masking will actually be applied. So for example, you can give the credit card function and that will know to mask all the digits except for the last four. Or you can give the email function, which will replace some of the account name and the domain with X's. Other functions include things like random numbers or even custom text. You can even choose a default function which will look at the data type of the data and figure out an appropriate mask on its own. And finally, let's quickly talk about which fields you should generally consider as candidates for dynamic data masking. The first and most obvious fields you should consider for masking are sensitive fields. Sensitive fields are fields that contain data that people really shouldn't be seeing freely. Often these are privacy type fields, but they can also be sensitive fields to businesses. So obvious fields are things like emails, credit cards, keys, and so on. But one of the more interesting things that you can do is pay attention to the recommendations in the Azure portal. Microsoft has been around and they've seen a lot of data, and as a result, they built a lot of inspection rules into Azure. So Azure itself can look at your data and spot what it considers to be sensitive data and flag it for you. If you agree with Azure's assessment, you can then go ahead and apply new data masking policies according to those recommendations. The last thing we'll talk about in this course is one more perspective on data security: encryption. There's actually two main categories of encryption: encryption at rest and encryption in transit. Let's start by talking about encryption at rest. Encryption at rest is about your data being encrypted while it resides in some persistent storage. Specifically, it means that the entire storage container is encrypted. And the good thing about that is it means that any data that you store in that container, regardless of its format, is encrypted while it's inside the container. So, whether you're storing raw data, blobs, files, full archives, or even your backups, as long as it resides in a container that supports encryption at rest, your data is encrypted. So, why is that important? Well, let's pretend that through some incredible scenario, someone got a physical copy of your database. Well, without the necessary keys, the data inside that database would be completely encrypted, and the nefarious individual wouldn't be able to do anything with your data. Now, in Azure, data encryption at rest is available in virtually all services. So, whether that's services delivered through SaaS or delivered through PaaS, or even if they're delivered through an IaaS service, Azure takes security seriously. And they have to, don't they? I'm sure you'll agree that Microsoft does not want to find themselves on the front page of the news because they exposed all of their client data in plain text to the world, right? Now, data encryption at rest is standard across the board in Azure, but not all encryption models are created equal. Azure has specific encryption models to handle things like file storage, but they also have models that handle entire virtual disks. Now, blobs are about the most basic type of data you can have in Azure, but they can be anything. They can be simple text files, images, videos, or even entire already encrypted system backups. Azure is able to handle that kind of encryption too. And of course, there's table encryption, and this is particularly true for relational systems like SQL. So while not all services are created equal, there are particular sets of encryption models that Azure uses. For example, client-side encryption can be implemented to perform encryption outside of Azure. So that includes encryption performed on a customer data center or by a custom client application. Or it can include data that's already been encrypted before even getting to Azure. In a client-side model, even Azure doesn't have access to the data in the database, but it does mean that someone else has to control the keys. Now, server-side encryption is effectively the opposite of client-side. With server-side encryption, Azure handles the encryption and decryption of the data as it enters and exits the system. Now, Azure is the one that controls the keys in that case. This is generally the simplest approach, but it does mean that there's a certain amount of trust that's afforded to Azure, as it will be able to see your raw data. Then there's disk encryption. Virtual machines can use Azure Disk Encryption to protect system storage disks using full volume encryption managed by tools like Windows BitLocker and Linux dmcrypt. The keys are then protected in an Azure Key Vault. Now, storage services in Azure will use server-side encryption, but you'll also have the ability to implement client-side encryption for a double whammy. As data is inserted to and read from the database, Azure encrypts and decrypts the data using a 256-bit key. Now, when you're implementing client-side encryption with systems like Azure Blobs, you don't necessarily have to roll your own encryption tool. In fact, it's recommended that you don't. Instead, Microsoft provides a library that allows you to encrypt and decrypt your data using industry-standard, tried-and-true methods. The difference then just becomes that you have complete and total control of the keys, not Azure. So if you're going to implement client-side encryption, it's recommended that you use client libraries from Microsoft to encrypt your data according to standards. Now, it's also interesting to specifically highlight data at rest within Azure SQL databases. Now, SQL databases support both client and server-side encryption, but the server-side encryption uses TDE, Transparent Data Encryption. TDE encrypts data files in real time using a database encryption key that's stored in the database boot record. TDE protects data using AES and 3DES encryption algorithms and is enabled by default. Now, the other type of encryption is called encryption in transit. Data encryption in transit means that your data is encrypted while it moves from one location to another. Data can be moved in all sorts of ways, so there's lots of different methods to encrypt data in transit. The first strategy refers to data link layer encryption. Basically, this is talking about how data moves from one Azure data center to another. Data is encrypted and decrypted on each end of the transmission, and that prevents a man-in-the-middle attack, meaning if someone were to sniff your packets as they were transmitted, the data would be encrypted inside those packets and therefore it would be useless. Now, one of the most common encryption in transit methodologies is transport layer security, or TLS. TLS is used for virtually all web traffic. If you've hit a website and you've seen the address is using the HTTPS protocol, that's because it's using TLS to encrypt your data in transit. Your browser does the decrypting. In fact, anytime you use tools in Azure, you're using TLS security. Transactions with Azure services like storage accounts are always through underlying APIs, and those APIs are configured with TLS. And that means that all your transactions to and from your various data services are encrypted. And if you've got virtual networks configured in Azure, SMB has been configured to make sure that all the intercommunication between services is encrypted too. But what about virtual machines themselves? What if you connect to a virtual machine in Azure? Well, when you connect to a VM using RDP from a Windows or Mac system, any data that transmitted over the network to and from the RDP session is protected by TLS. And with Linux VMs, there's other options too. In fact, you can use the Secure Shell or SSH to connect to Linux VMs in Azure. SSH is an encrypted protocol of secure connections to unsecured networks, like the internet. In fact, it's the default protocol for Linux VMs in Azure. Another common connection strategy is VPNs. Virtual private networks are a very common strategy for connecting different networks together. VPNs can add to your security profile, but they can also be an attack vector. So there's a few different types of VMs that mitigate that. Azure VPN gateways can send encrypted traffic between your various networks, virtual or on-prem, across any mixture of public and private connections. Meanwhile, point-to-site VPNs enable individual client machines to access an Azure virtual network. So Secure Socket Tunneling Protocols, or SSTP, is used to connect the VPN tunnel, and it can go through firewalls because the traffic is all HTTPS. And this is a very common strategy for putting physically disparate systems onto the same network. In fact, I use this strategy to connect all of my developers into a single virtual network, even though the developers are all over the world. And then there's site-to-site VPNs. Site-to-site VPN connections can be used to connect on-prem networks to an Azure virtual network through an IPsec tunnel. Importantly, this type of connection requires an on-prem VPN device with an external public IP. And finally, let's quickly talk about encryption in transit with data lake stores. With data lake, data in transit is always encrypted. Data movement from data lake is always through a REST API interface. And if you're using client libraries or tools like Azure PowerShell, the data is actually moving through a REST API over HTTPS. In fact, HTTPS is the only supported protocol with data lake. And so that means that with data lake, TLS is always on. So in this course, we've examined Azure non-relational data types and stores. And we did this by exploring types of Azure non-relational data and data stores, creating an Azure Cosmos DB and an Azure Blob storage container, creating Azure Data Lake Storage Gen 2, and Azure Dynamic Data Masking and Data Management. In our next course, we'll move on to examine Azure Machine Learning Data Stores and Compute.